All right, here we are in the soil processing area. It's a greenhouse space that we cleaned up a couple years ago to turn into a place that we could do work, handle, process, explore soils in a variety of different ways. This will be the starting point, and then actually we're going to walk over to the soil pit that's just right over 100 yards away here at the Chico State University farm. So in preparing for our class that we thought we were going to do face-to-face, we got the pit that we're going to go to and our older pit that's right over here. You can see the soil pile. And there we've got a deep 7-foot pit with all kinds of interesting things. The gravels at the bottom of this other pit that you saw aren't as prevalent there. And we'll come to that pit back a little bit later in the semester. Okay, so here we are. We're back at the pit. Really excited. This is the second time back to this pit. Remember we did a nice simple profile characterization before. This time we're out to collect samples, right? Simple affair. Got some buckets so we could fill up and have plenty of soil to work with. I got a knife. We already delineated the horizons, which makes it even easier, but I just want to go back over it really quickly, right? So nice, thick, beautiful soil. Best soil on earth. Now that's a challenge to anybody else out there to show me the best soil they have on earth. And here we got a deep, rich mulsol, young soil deposited within the last, geologic period. And we realized that we had a nice A horizon up here, surface horizon, granular, all that kind of stuff. I'm gonna call this second A horizon, I'm gonna call this the thick, nice, thick A horizon sequence. Then we get into the subsoil, the B horizon, right? And that's the zone of accumulation. And you can see the color change. You can see the change in the structure. And you can see some bedding, see how it holds the marks. Then we get down a little bit lower and we're into that true parent material, C horizon. This is fairly undifferentiated, right? It's not aggregated as nicely as this. And you see, once again, a drop in color. Right below that was the old stream bed that was sitting here, and you can see how clean it is, and you can see some evidence of some accumulation of iron oxides and other things down in the profile. Pretty cool thing for us to talk about for the rest of the semester. So now I'm going to get to this sampling, and so we can start talking about particle size and texture.
So I'm just going to talk this, cool. So I'm just going to talk out loud one, so here we are, we're trying to get a time lapse of me sampling the soil, getting it out, getting lots of it, right? Have my belly stick out. After this elevated A horizon, I'll be all right, right? Ready. That's right. Remember, have buckets ready. Oh, I need to work for the rocks. It's gonna look like me struggling.
Here we have the profile is sampled from the surface soil, the upper A horizon here with the knife for scale. You can see these beautiful aggregates that came out and their sub-aggregates, granular structure. Even right there, you can see those little bubbles. Those are probably like a crotavina or a filling of a channel. Then we're gonna move down to this second surface horizon. Same deal, you're starting to see a little bit more consistence, but still that beautiful dark color. If we wetted this up, it would really pop out. Then we drop into this subsoil horizon, right? Zone of accumulation. We still have aggregation, but it's not as consistent, a little bit more rounded, that kind of stuff. But we see biological activity in pores and roots and all that kind of stuff. Then we get down to the very bottom, that C horizon material. You can see the contrast in color between these two. That's more organic matter, this is less. This you can start to see clean mineral grains in the gravels and some of the fine sand, some of the sands. This is less differentiated. And then remember, this would be the material that was first deposited on top of that river channel with those gravels and cobbles. So here we are back in the spa. We have a bunch of different processing capabilities here. Today we're going to be looking at our mechanical shaker, a number 10 sieve, which will get us down to less than 2 millimeters or exclude things larger than 2 millimeters, and a common Costco baking pan. Everything we try to do in here, as we talked about before, is from the hardware store, from restaurant supply. We don't want to spend extra money on sampling equipment when we can get it at a much cheaper price when we try to do it ourselves. So what we're going to do right now is we're going to start sieving these samples. Remember, here is our beautifully aggregated surface horizon. You can see the granular substructure and the larger aggregation. And you can start to see things that maybe are gravels or larger particles. We're going to take this sample, we're going to put it in the sieve, kind of crush it up to start. See how easy that crushes when I break it between my hands? It really just wants to come out. But then you get these substructures which look like the original, right? This little piece looks not too different in shape to this bigger one. And that's kind of a symbol of what aggregation really is. So I'm going to break this stuff up here, get it in a first level form. I might have to grind it a little. It's nicely cemented. It's not very moist. Sometimes dry soils stay together more than moist soils, right? So we're going to get this thing going. We're going to put it on our shaker. Funny side story why this has a wooden top. When we got this instrument, it didn't say on the specs that top was required separately. So it got here and we didn't have any more grant money, and it cost quite a bit of money to buy just the top. So we ended up making one out of plywood, and it seems to work just fine. We're going to turn this thing on, and we're going to run it here. Is it not plugged in? Not plugged in. Safety first. There we go. And we're just going to shake this for about a minute, 2 minutes to disaggregate and get that scent, that particle size distribution. Or not. Oh, that thing's super low. Somebody had it turned down to 0. This could watch it cross the amplitudes. It's starting to move a little bit more vigorously. Wow, this thing's poking along right now. Usually it blows up. Why is this thing not? There's your time lapse. Huh, that's crazy. What's going on with this thing? This thing is... Huh. Dude, that's strange. No, it's not doing what it's supposed to do. Does it even turn on? It's on. I mean... Because I only pushed the amplitude and it was only wiggling because I was touching it. So here we ran it for about 2 minutes at the 100 amplitude, which this instrument has a mechanism inside that's supposed to pitch the samples up in an optimal way for them to get oriented and to fall through the sieves if they're supposed to. So we're going to take this thing off the grinder and see that not everything came out as fine fraction. This is still a lot of aggregated soil, but you can start to see where it was being rounded and broken down by the sieve. Inside that 2 millimeter, we have our fine fraction soil. This is what everybody talks about with those 3 particle sizes, right? Sand, silt, and clay. This 2 millimeter sieve excludes things larger than 2 millimeters and allows everything less than 2 millimeters to fall through. So you could start to work with this soil and do a bunch of other things we're going to talk about this semester. All right, now we have a nice pan of 2 millimeter or finer fine fraction soil. And we're going to put it in this tin so we can give you an idea of what it looks like between the nice aggregated soil and the fine fraction soil that we've used through physical fractionation. We're going to keep going. We're going to sieve out the rest of these buckets. Here's bucket number 1. And then we're going to sieve out the rest so we have enough sample to work on over the rest of today and over the next couple episodes. All right, so now we have all of the soils that have been separated from their aggregated form here. The surface A, the second A with a little bit more aggregation. You can see getting into a BW that starts to pick up some gravel and some of that coarser material underneath, and then down into that true sea horizon with less aggregation. And the example of these fairly clean, fairly defined gravels in there. So now we have soils to be able to do particle size distribution via sedimentation, and we'll be hand texturing these later on at the soil area. See you later. Here we are. We left the farm after our last segment of sampling and processing, and now we've posted up in Irf's front yard in beautiful downtown Chico. What we want to do now is we want to move on from field and sampled soils. We already sieved them down to less than 2 millimeter fraction, which is sand, silt, and clay-sized particles. And then now we're going to show you about hand texturing and set up some other analysis moving into the coming weeks. So if you remember, we had a couple of nice dark A horizons here in the surface, and even between those you can see the difference in the structure with the granular structure and the bigger subangulars, less and a change in color. Getting down into those subsurface horizons, remember we talked about the zone of accumulation, the B horizon, and then into the C horizon of stuff that is sandier and more like the parent material that was deposited by Butte Creek sometime in the past. So why do we do this? We really want to know, we want to think about soils as this dynamic thing, but we also need to know about variables that are meaningful to help us predict properties or the effects of management on soil properties, ecosystem services, and those types of things. So one of the things that happened early on in soil science was physical fractionation, being able to take a soil and break it down into its constituent parts, especially its physical fraction of particles. We could talk about rocks and larger aggregates that we would collect in the field. We showed you in the video just a little bit ago how there was gravels and cobbles in some of these samples. Now we're going to work through and get to the point where we can show you that by just using your hand, this sample, and a little bit of water, you can get a pretty good estimate of the soil texture, which remember is the percentage of sand, the percentage of silt, and the percentage of clay. That takes us to our first prop of the day, which is the textural triangle, right? This and the soil color book are probably two of the most iconic things in soil science. This textural triangle is a ternary diagram that allows you to take 2 or 3 of the percentages of the classification categories, sand, silt, and clay, and provide a nominal classification from sand and sandy loam down here in this corner, over into the silty soils, and then up into the clays, high clay content soils up here at the top of the triangle. We would talk generally, and since part of our goal in the College of Ag is to get you prepared to work in the field, you might hear terms like coarse textured, fine textured, loamy, clayey, things like that, and that's all related to this textural triangle. Like I said, this is pretty iconic, right up there with the color book that we'll talk about in a couple weeks. So we're going to use our hand and try to calibrate it related to this triangle. How are we going to do that? Well, first we're going to take soil and water and we're going to work it up into a textural ball that will allow us to use our very sensitive pressure meters in our fingers, along with thinking about grit, plasticity, stickiness, and some other morphological or physical features, and allow us to understand generally what classification the soil is. So I'm just going to take some of this soil right now, and I'm going to make a mess. Normally we'd be at a pit. I'm trying to sit at this table, which is excruciating. I want to get up and walk around, which is totally fine. But I'm going to show you how to make a texture ball right now. So fill up your hand with some soil, and then you're going to add some water. So I'm using some of Earth's fine pottery that he produced at the beautiful Chico State ceramics facilities on campus. And you're going to wet up a soil. Now, this isn't ideal. A lot of times you might have a little spray bottle or a wash bottle like you would have in chemistry that allows you to control the amount of water that you add, how fast and where you put it. One good thing is that no matter how wet you make it, you can always add more soil. So in this case, we got this nice ball started. It's a little drippy, a little juicy, so I'm going to add a little more soil to it. Just like baking cookies, right? You want to get the right consistency. You don't want it too juicy, and you definitely don't want it too dry. You want these particles to kind of adhere to each other and start to interact with each other. Part of that is related to the colloidal components or the finer fractions in here that we talked about these last weeks in the videos. Thinking about the silt and the clay fraction and how when you add water, these things want to start sticking together. So I'm going to work up this ball here, and then we're going to, I'll work up the rest, and then we'll return to talk about the texture of these different texture balls here across this horizon. All right, so we took a moment and worked up these 4 texture balls from our surface down through the profile. Once again, just wetting these samples up, you can really see the contrast in color, but then you also realize that wet soils often can also mask some of that color. It can make everything darker. You can see here a really nice dark surface soil down into that second horizon. Then you start to lose some of that organic matter and some of that darkness, and then down into the primary parent material in the C horizon. So how do you learn how to use your very sensitive pressure meter in your fingers to texture a soil into one of those textural classes? We're going to work through this kind of handy flow chart. You can find this on the internet. I'll post it for you too. And it's really just trying to use the concepts of cohesiveness, grittiness, and some others to categorize. So you always start at the top with your soil ball, and it really gets into a choose your own adventure. If this, then this way. If not, this way. And you start with the easiest ones, or the ones that, in this case, you start with the sandier soils, and you work your way down until you get to the finer textured soils. So in this case, we start off with make a ball, and then will the ball remain a ball when squeezed, right? And so on. And we're going to go through that right now with me on screen and Irf as the narrator.
Cool.
So we have our first ball. If I squeeze it, does it remain a ball? Yes.
Yes.
So what's the next step?
Place a ball of soil between thumb and forefinger gently, pushing the soil with the thumb, squeezing it upward into a ribbon. So the next step is, does the soil form a ribbon?
And it does, slightly. That's about as far as it'll go. I have to hold it up. That's about 2.5 centimeters. If I let go of it, it'll fall off and broke into that piece. So it will make a ribbon, but just not a very big one. We're not going to get to the full spectrum. We'll come back to this later, but sometimes with really clay soils, you can make a ribbon that is, 7.5 to 10 centimeters, or 3 to 4 or 5 inches long with a really clay soil. This one we got about an inch, about a 2.5 centimeter ribbon. So what happens if we made a ribbon, Irf?
Well, the breakout for the ribbon is actually 2.5 centimeters long. So the actual criteria is a weak ribbon less than 2.5 centimeters long.
I think we'll go slightly over 2.5 centimeters to make it slightly finer textured than that first cutoff.
Okay. So the next step is, so that would put it...
See there, you can see that one pretty good. That's clearly greater than an inch in its ribbon.
That would put us in a medium ribbon length of 2.5 centimeters to 5 centimeters long.
Okay.
So that takes us to the next step, if yes, is excessively wet a small pinch of soil in the palm and rub with the forefinger.
Okay. So let's take a little bit of water here and pour it on. This is a great one, no matter what, even if you're not trying to hand texture, to really look for sand and look for sand content. You can rub this thing into a little ball, and you can start to think about, do you see gritty sand particles or not, right? We're trying to eliminate how much sand we might have, or how much sand content we have in here. So when you get in there close, you can see a decent amount of sand in there. It's not super sandy, but decent amount. We'll rub a little more in there to give you a little bit of better look.
Can you pull back just one?
Yep.
Yeah, perfect.
There we go. So what's the criteria we're looking for in this one, Irf?
Does the soil feel very gritty?
It's pretty gritty. I mean, we can see a variety of different sand particles, coarse through medium sand, and even some finer sand. When I pull my finger away, I can feel the softness of some of the smaller particles that aren't sandy. So I would say it's gritty, but not very gritty. Is that one of the breakouts in there?
Yeah, so is actually, does the soil feel very gritty?
I would say no.
No. If no, then the next question is, does the soil feel very smooth?
No, it's in between.
Okay.
Is that a classification?
Yes.
Good.
It is.
Oh,
So
fantastic.
our next and final classification would be neither grittiness nor smoothness predominates.
I think that's fair.
So that would bring us to a clay loam.
Ooh, wow. Maybe that might be a little bit finer textured than, or that might be a little bit more clay than is actually present in this case. But let's move on to the next one.
So now,
So we worked up these balls. Like I said, it's like a pizza dough. You don't just take some flour and sugar and yeast and pour it together and expect it to be a dough. Sometimes it needs a little bit of extra work. So adding some water to make sure it's the right consistency, the right moistness, and so on. So same deal, we'll do the same. Will it hold the ball? Yes, it holds together nicely. And then we would start our ribbon. So this one really doesn't want to hold together as much. And this is where sometimes organic matter content can be a confounding factor. It can help bind things up and act like a clay when it's actually not a clay in the mineral sense. And I suspect that's what's happening here. I also haven't textured a lot of soils lately, so the amount of sand that was in my hand there might be considered very gritty, and that would have taken us down the path more toward the loam or a sandy loam. This being a clay loam, I suspect might be a little bit off in our calibration. Now, what happens is in this is that you learn about doing this in a class and you do it once or twice. You really never learn about these things until you get a lot of experience and a lot of practice, and work with people that have very calibrated hands. You can work with an active soil scientist like Andrew Conlon here in Chico, and you hand him something and he's spot on. He can take his assessment with his fingers, check it versus legitimate lab data, and he's always going to be within a percentage or two of the actual numbers because he's textured tens of thousands of samples across his career. So he really knows what's going on. The number one thing to remember is you don't have to be perfect, but you also don't want to be crazy wrong, right? So that's why if you're uncertain, you don't have to be an expert. You don't have to act like, oh, this is definitely that. And sometimes people that act that way are the ones that get called out right off the bat because they think they know what's going on, but they don't really. So I think I'm going to leave it right there. We can continue to work our way down. The one thing that you would find is at the bottom that this one really does lose its clay content. And actually, if we were to get the sound of this on the microphone, you can actually hear the sand as you crush it in your hand. And this is where some of these things cross over. It's not just about the tactile nature. It's about listening, looking, and feeling, and understanding where those breakpoints on that diagram lie. So I think for now that's enough for this episode. We're gonna try to in the next week we're gonna start talking about color. We'll probably wrap back around to texture with some laboratory measurements using the density fractionation and sedimentation approach. I'll cover that today after the video to give you a heads up on that. And then we're just going to keep working our way through week in and week out and learn as much about soil as possible and connect it to everything in your life. So with that, have a great day. Enjoy the good weather while it's here, and we'll be talking to you again soon.